Welcome to today's video. I'm aware yesterday's video was quite difficult, really a bit depressing, and there are difficult times ahead. But today's video is just pure good news all the way through. And the main bottom line of this video is I'm expecting the Oxford Astrazeneca vaccine, which is cheap and can be transported at normal fridge temperatures, to be authorised by the UK authorities just after Christmas. I'm expecting that to be authorised this year. And I don't think it's too much of an exaggeration to say that this is going to change the world, or certainly change the world of the pandemic. And through that, the world, it's going to be massively significant, as we'll see. Now, just before we do that, just a bit of an update on the Pfizer and the Moderna vaccine. Now, the Moderna vaccine, the Moderna National Institutes of Health vaccine, is approved now by the FDA. So that's going to be rolling out by the million from Monday throughout the United States. So seriously good news. But we'll come on to that in a minute. Just the Pfizer vaccine first. So the Pfizer vaccine, in terms of UK distribution, well, 400 GPs and 83 hospitals now distributing. 500,000 doses so far, 200,000 doses a day. Over 1 million people receiving the vaccine by Christmas. So it's just a start, but it's not a bad start. It's not a bad start at all. Now, the UK's not got infinite amounts of Pfizer vaccine, and it's going to run out. The UK's only got 40 million doses of that, so we're going to see the Oxford vaccine is going to be the main game changer as far as I can see it. But carrying on with this, Pfizer think they can produce 50 million doses altogether globally by the end of 2020. So that's good. That's a good start. Now, the United States has ordered 100 million doses with options on up to 500 million, 500 million doses for the United States. European Union, 200 million. The UK, a total of 40 million altogether. Most of those, of course, won't arrive until 2021. And the European Medicines Agency is reviewing the Pfizer vaccine. They were going to review it on the 29th, but under significant pressure from Germany and Spain, and indeed the frustration of basically all of the European countries, it's brought that announcement forward, and we're expecting that on Monday the 21st. And of course it's going to be positive, because it's been positive from the British authorities, it's been positive from the American authorities, it will be positive from the European authorities as well. So we're expecting that Monday, possibly Tuesday. So later than we would like, but still good news. Moderna, fantastic. FDA grants emergency approval, absolutely brilliant. Taking a bit longer than we'd like, but they're going to be rolling out the Moderna National Institutes of Health vaccine on Monday. So this means that throughout the United States, the Pfizer and the Moderna are well on the road, being injected. Mike Pence has had his, Mrs. Pence has had hers. We're on the way. Looking good. 6 million doses of Moderna ready to go next week, we believe, from stockpiles in the United States. So, this is incredibly good news. Now, it's not going to change herd immunity for a few months, because we've got a lot of people to vaccinate. But it really is the beginning of the end. We really are now beginning the end part of this pandemic. So, for the UK, the end begins just after Christmas. This is the Oxford Astrazeneca vaccine. Now, we believe this is going to be given final approval for use within days of Christmas, probably the 28th or the 29th of December. So it will be approved this year. Just at the end of this year, the Oxford Astrazeneca vaccine will be approved. This vaccine's very cheap. It's way cheaper than the Moderna. It's cheaper than the Pfizer vaccine, way cheaper. And it can be transported at normal freezer temperatures. The logistics are really quite simple compared to the Pfizer vaccine, for example, which has got to be transported at the lowest temperatures. So this is not just me musing on my own. This comes from senior Whitehall sources. Now, it could be that the senior Whitehall sources are wrong, but these conservative civil servant types tend not to speak unless they're pretty sure. So they are suggesting strongly, and we believe that the Medicines and Healthcare Regulatory Agency, that's the British equivalent of the FDA or the European Medicines Association, the MHRA, is going to approve this Oxford vaccine on the 28th or the 29th of December. That is what I expect to happen now. I was hoping it would happen last week, but they are waiting for more data to come in from the United States. And the last of that data we're expecting to arrive on Monday. So Monday the 21st, I think it is. So that will give them about 8 or 9 days to finalise that data. That doesn't mean to say they'll be starting to crunch it then. They've been working on this flat out all the time because they're getting the data on a rolling basis. They're not just waiting for it coming all of a sudden. So final approval, for final data is going to be provided to the regulator on Monday the 21st of December, although they have a lot of it already, but that's going to be the last bolus, if you like, of the data that they're going to need. Now, 4 million doses are ready to give out for the UK, and hopefully by that time the FDA, or shortly after that, the FDA and the European Medicines Agency will also authorise the Oxford vaccine. But the UK is going to authorise the Oxford vaccine first, almost certainly. There's no jingoism here. I just want this done. Hopefully the other agencies are going to authorise it round about the same time or shortly after. So the UK is going to be using football stadiums, racecourses, conference centres, pharmacies to get this vaccine out by the million. And this is going to start big time from January. So think the Royal Albert Hall in London, the National Exhibition Centre in Birmingham, Earl's Court in London. All these, basically we're going to use anywhere and everywhere and get this vaccine out. It's going to be the biggest vaccination programme ever, and it's going to be the quickest ever. And it's going to make a massive difference, quicker than I had hoped. We're not there yet, but quicker than I'd hoped. So that's going to kick off on the first week of January, big time. By the end of January, a lot of people will be vaccinated. Several million doses a week, and that's only going to ramp up. That's good. And I'm pleased that the government is using existing health services. They're not getting in outside contractors. This is going to be done by people who know their business. UK, 100 million doses. So the UK has ordered 100 million doses. 80 million of those are going to be produced in the UK. Now, apparently we've made loads of this stuff now, but we're just having difficulty putting it in the vials. But that's a manufacturing thing that will be soon fixed. Other great things about the Oxford vaccine. India. Now, in Pune, just near Mumbai in India, they've got the India Serological Institute. And they've made 50 million doses of the Oxford vaccine already. It's just sitting there ready to go. 50 million doses ready to go. Such a good news, and they can produce huge amounts at a very reasonable price. We're looking at about $3 per shot for this vaccine, and that is basically going to mean that people all over the world by the billion are going to get this vaccine who couldn't have afforded it otherwise. First batch of 4 million doses are coming from the Netherlands and Germany, but this manufacturing problem will be sorted out within days, certainly within weeks. And time for the approval now. I am concerned now. The Chinese vaccine and the Russian vaccine, people in poorer countries are going to be using that vaccine, but we just don't have the data on it. It would be so much better, given that the Oxford vaccine is going to get approval on the 28th to 29th of December, just in a week or two's time, to use the Oxford vaccine, because that's been through every possible check as normal. I would not feel comfortable receiving or giving an untried vaccine. Well, I simply wouldn't do it. I would refuse to give it or to receive it. Whereas the Oxford vaccine I will be delighted to receive, I will be delighted to give, because it's been through all the rigorous trial processes. So Astrazeneca has 15 million doses of active ingredients ready to be put into the vials in days. So basically we've got 15 million doses ready to go when the approval is granted at the 28th or the 29th of December. 2 doses with a 4-week gap. Leaving an adequate gap between doses is the most crucial way to boost efficacy. So this is what seems to be transpiring here, that this gap In fact, there's evidence that even a longer than a 4-week gap might be good, but the 4-week gap seems to be the pragmatic timing that they've chosen. Then that is the 4-week. The thing about the 4-week gap is it does mean that people will be vaccinated, and they're not going. They might develop some immunity, but they're not going to get full immunity, as we'll see later on, until a week to 10 days after the second dose. So we are talking some lag time for the immunity to build up. But it will build up, as we're going to give evidence for. Now, the Oxford Astrazeneca vaccine orders. The manufacturing capacity for this is about 3 billion, I think 3 billion doses in 2021, because it can be produced in many different places. So orders so far, the European Union 400 million, that's enough to transform the European Union. The UK 100 million, the United States has got dabs on 300 million. I think the United States will probably start using this as well, partly because the Moderna vaccine still requires -20 and the Pfizer vaccine requires -70, whereas this requires something like 2 to 6 degrees centigrade. I don't know what that is. It's about 34 to 40 degrees Fahrenheit. So normal fridge temperatures. China 200 million doses, Japan 100 million, Brazil 100 million. These are all advanced orders. Australia 33.6 million, Egypt 30 million, Argentina 32, Canada 20 million. So basically this is the vaccine that most people in the world are going to receive, I believe. The Oxford vaccine is the one that's getting in at the right time with the right characteristics. I mean, the Pfizer vaccine and the Moderna vaccine will carry on massively, of course. But the logistical problems in transporting is going to make it harder, especially for poorer countries. Now, another good thing about the Oxford vaccine is Argentina and Mexico are going to produce all the vaccines that are going to be required for Latin America. So there we cut down the international transport of the vaccine. It's going to be produced relatively locally. Another wonderful thing is the Vaccines Alliance for Poorer Countries has got 300 million doses booked, and I think paid for. So a good start for poorer countries, and they can produce globally in many different manufacturing units 3 billion doses in 2021. So that is just remarkably good news for the Oxford vaccine. So to summarise that, the Pfizer vaccine's getting out now. The Europeans will be authorising it next week. It's already being given out in the United States, Canada, the United Kingdom. The Moderna vaccine will be rolling out in the United States as from Monday. Canada, I think, has got some Moderna vaccine. The United Kingdom is not getting Moderna vaccine till March. 7 million doses arriving in March of the Moderna vaccine. We probably won't need it because the Oxford vaccine will be up to speed then, I am expecting. Now, that is sort of the good news part of this. And the next part is good, but it's probably take about another 10 minutes to do this if you want to stick around. I'm going to stick around and do it, so do stay with me. But what we're looking at is there's a phase 2 paper on the Oxford vaccine as well. So the Oxford vaccine, this is the third peer-reviewed publication on it now, and they're giving more detail from the earlier stages of its development. So interesting if you want to stick around, a bit more scientific if you want to stick around for this. Do. If you don't want to stick around for this, of course, I understand. Have a good day for the rest of your day, and for those of you that are staying, it is well worthwhile. It's very interesting, actually. So phase 1 / phase 2 trial of Oxford vaccine with a booster dose induces multifunctional antibody response. Right, well, what the heck is this talking about? Let's look at it. So this vaccine is a viral vector. We know it's a chimp. Virus. It's an adenovirus, but it's carrying coronavirus antigen. So we know it's been put into that. So when this gets into the body, the full dose is going to be 50 billion adenoviral particles, each of those carrying the antigen for the SARS coronavirus 2 virus. So the body will learn to recognize it. Interestingly, there's 190 vaccines in development. I mean, wow, that's all. I mean, a lot of these won't come to fruition, of course, but a lot going on. So neutralizing antibodies against the viral spike protein correlated with protection. That's the first thing they note here. Now, what this means is, as we know, the SARS coronavirus 2 has got these spikes that are how it is infectious. That's how it's infectious. So the neutralizing antibodies are specific to the spike protein, and they sit on the spike protein here. And that means the spike proteins are all gummed up, glued up, clarted up, blocked with antibody. So that means that these spike proteins can no longer fit into the ACE2 receptor sites on the cells, and that means that this virus is no longer infectious. That's what we mean by neutralizing antibodies. And what the authors say here, when they say that the number of neutralizing antibodies correlates with protection, it means the higher the number of neutralizing antibodies, the better. So that is accepted. But there's an additional antibodies. Functions may be important in preventing infection. So as well as these neutralizing antibodies, the Oxford vaccine is inducing other antibodies as well. So what the other antibodies can do, as well as neutralizing, so that the antibodies can neutralize. But the other thing that antibodies do is, you might remember that antibodies are these Y-shaped proteins, and they have two arms, so they can grab onto things. So I can grab onto a virus with that hand and grab onto a virus with that hand. And that means we can end up with big clumps of virus because we have different types of antibodies. So what happens here, as well as the neutralizing antibodies, is imagine that imagine we have these these are viral particles here. And because the antibodies have two arms, one can grab onto there, one can grab onto there. That's the body of the antibody there. And now those two are stuck together. But then we have another antibody grabbing onto this one here, like that. Now we've got three stuck together. But then we have another antibody grabbing onto these two like that, and they're stuck together. And another one there and there, and they're stuck together. So I think you can see what's happening here is we're going to end up with great big clumps of the virus. This is called agglutination. So we end up with big clumps of the virus all clumped together. So we get this agglutinating effect. And when the viruses are all clumped together, they're not free to float off and infect other cells. So that's also good. And the other thing this vaccine induces is it induces a cellular response. And that means we can have a process called phagocytosis. Phagocytosis. Now what this means, in phagocytosis, what we have is, imagine that's a big clump of these viruses all agglutinated together there like that. So that's it, that's all those all agglutinated together, all those viral particles. So we've got a big clump of them all stuck together there, maybe a couple of clumps. Then what we have in the blood and the tissue fluids is we have great big cells. So for example, there's a cell called a macrophage. Macro means big. Phage means to eat. So these cells are big eaters. They are macrophages. They are macrophages in the tissues that come from monocytes in the blood. Anyway, so these are great big cells like this. Very large cells. And what these will do, these cells will migrate towards the viral particles. They will move, they will flow their cytoplasm towards and kind of roll towards this. And then when they get to the viral particles, what happens is, if we imagine that the scene a minute later, so here's the viral particles, they're like that. And now this cell's arrived, and when it arrives, it doesn't stop moving, but it kind of carries on. So it ends up starting to engulf these, that's the nucleus of the macrophage. It starts to engulf these viral particles. And then these arms here come round, these are called pseudopedia, these false feet come round like that, as the cytosol flows into these. And what it means is you end up with these viral particles all clumped together by the antibodies. And what it means is, if that's the macrophage there, or the macrophage's nucleus there, then these here all end up completely in a vesicle, completely inside the macrophage there. So the virus is now trapped inside this vesicle, inside the macrophage. And then if we imagine here, we have extra organelles in here called lysosomes. And these lysosomes contain a digestive enzyme. So what happens now is, if we imagine that is the vacuole inside the macrophage with all these viruses here, then these lysosomes come next to this like this. They come next to that vacuole. So on this scale they will be here like this, on that scale. And then what they do is they release digestive enzymes such as lysozyme into there, and that simply digests all those and breaks them down into their constituent proteins. Then they can be absorbed as amino acids and things, just as a normal nutrient. So they will be completely destroyed by these macrophages. So what we say is the antibodies prepare the food for the macrophages table. The antibodies clump it all together, then the macrophages come along and literally eat the lot. That amazing process of phagocytosis. So that is what is happening there. So additional antibodies function in many ways, such as phagocytosis by these great cells called macrophages. Big eaters, macrophages, gobble them all up. Now, in this study, there was 2 jabs 56 days apart, much longer than is being used in practice. Now, the patients that were followed up here, relatively small numbers because it was phase 1, phase 2, and some got standard dose, 20 of those, and some got the standard dose and the lower dose, just to see how effective it was with lower doses of the viruses. So the standard dose was 50 billion viral particles, adenoviral particles. The lower dose was probably about 22 to 25 billion viral particles. And the study claimed a booster dose is safe and better tolerated than a priming dose. So that's interesting. So the people that got side effects from the vaccine got more side effects from the first dose than from the priming dose, the second dose. And we don't know the full details yet, but people do seem to get a headache and fatigue after some of the other vaccines. So this may turn out to be better tolerated, although I don't have full data on that as yet. So in other words, what we're saying is it's not just neutralizing antibodies, it's agglutinating antibodies. And as well as that, this study shows that once these viruses are agglutinated by all these different antibodies, these big cells, these macrophages, will come up, engulf them like that, and then digest them once it's inside the cytoplasm of the macrophage. And the Oxford vaccine has been shown to stimulate all of these immune actions. It really is quite a holistic immune response. But there's more yet, and the news carries on being good, actually. After the second dose, so there's increased anti-spike neutralizing antibody titers, which is good. We know that stops the infection. We're not knocking it. We're saying it's good. We're saying there's other things as well. And there's increased cell-mediated immunity. So these cells are the neutrophils and the monocytes and the macrophages. Now the neutrophils are also phagocytes. They're just smaller. The monocytes are phagocytes, but they live in the blood. And then when the monocytes go into the tissues, they become the macrophages. So the monocytes are called macrophages once they are in the body tissues, and they patrol the tissues. Quite amazing. They patrol the tissues eating viruses and bacterial particles. The neutrophils are just smaller. The neutrophils, you might remember that from biology. The neutrophils are polymorphonucleocytes. They have like a lobe nucleus like this. That would be a neutrophil, and they have granules in their cytoplasm. These are also capable of phagocytosis. So what we're saying is neutrophils can phagocytose. After this vaccine, they're sensitized to phagocytose. Monocytes are sensitized to phagocytose. Macrophages are sensitized to phagocytose. We really are the whole army of the immune system. Air power, land power, and sea power is all being massed against this virus. Sounds really good, doesn't it? There's also increased complement activity. Now, complement is a protein. What complement will eventually do is it will destroy viral and bacterial cells, as well as stimulating other aspects of the immune system. There's also increased natural killer cell activity. Now, we have mentioned these NK cells before. So lymphocytes can be divided into two sorts. There's the small lymphocytes, which are the B and the T, and there's the large lymphocytes, which are these NK, these natural killer cells. And what the Oxford vaccine does is it stimulates the activity of the natural killer cells, the NK cells. And it puts the NK cells on the lookout for the cells that are infected with the virus. So what happens here is, if we imagine that's a cell there, that's a virally infected cell, and it's got viral particles inside, like that. So that's a virally infected cell. Now, if we leave that to just live its own life and carry on, what will happen is that the cell will die, and these viral particles will burst out, and thousands of them will go on to infect other cells. So what the NK cells do is these are the big lymphocytes. They actually recognise, well, when the virus is in the cell's quite clever, and it puts out viral particles onto its surface to say, "Hoi, immune system, I'm infected here. Come and kill me," is basically what it's doing. So the lymphocyte, the large lymphocyte, the NK, recognises these viral residues on the surface of the cell, and it drops chemicals on this cell and simply kills the whole cell. But in doing so, kills all the viral particles inside. So these NK killer cells are sensitized by the vaccine to recognize these immune residues on the surface of human body cells that come there as a result of viral activity within the cell. So it sensitizes natural killer cells as well. Increased natural killer cell activity. Now, the standard dose and the standard dose vaccine given together produced a stronger antibody response, they found, than given the lower dose the second time. The T cell response did not increase with either vaccine dose. So in terms of killing these cells, there's two lots of cells that will kill cells. There's the cytotoxic T cells, and there's the natural killer cells. So what this is saying is that the T cells were boosted by the first dose of the vaccine, but when you gave the second dose of the vaccine, it didn't increase the number of sensitized T cells, but it did increase all the other aspects of the immune system. And it's always a combination of these effects that are going to eradicate the infection. So the authors conclude these data support the two-dose vaccine regime is now being evaluated in phase 3 clinical trials, and as we know, the data is going to go through to the MHRA on Monday. So there we go. Scientific evidence that the Oxford vaccine induces a lot of immunity. Good data that it's safe, as is true with the other vaccines, as is true with the Moderna and the Pfizer. But the Oxford vaccine, it has to be said, is all this information I've just given you is published in Nature, the journal Nature, the medical division of the journal Nature. So we now have 3 peer-reviewed publications, so we simply know more about it, which is great. So millions of people in the UK will be vaccinated by the end of January. Now, of course, we've got a lot of problems before then. I mean, I've just talked to my brother today, and obviously he wants to come up with his family for Christmas. No, can't. And we plan to have a perfectly normal Christmas, but in March, potentially April, one or the other. We'll do it then. Just put it off by a while, it's no big deal. It's only a time of the year. Okay, thank you for watching and being patient. Let's just have a few pictures. We won't have many pictures now because I've gone on quite a bit already. But these are from Mike in New York City. If I can get the technology together. There we go. I think this is in... I think he said this might be in Queens, I'm not sure. Anyway, 100% mask wearing, which is excellent. Bit of a queue there for a bank. They're a bit close together, to be quite honest. but good to see that people within the bank are being limited in numbers. Subway, always a high risk. Now, I do believe the ventilation on the subway system in New York has been improved. So these empty seats and everything and the masks are all absolutely wonderful. And of course we have 100% mask wearing, which is excellent to see. But are there viral particles hanging in the air? More likely if it's poorly ventilated, much less likely if it's well ventilated. But I believe they are starting to ventilate well now, which is good news. Elevator protocol, one at a time. Excellent. Common sense poster, but some people don't realise. This was outdoor dining. Now, he said the temperature. He said the temperature here was 31 degrees, which is like 1 degree centigrade. It's just over. No, 31 degrees is just under freezing. It's like minus a half a degree centigrade. And yet some brave souls are dining outside, which, to be fair, is relatively safe, especially with the this couple here, I would hope, are in the same household. So good to see that people are managing to carry on their businesses in a semblance of normal life. But I think I've shown today, I'm totally convinced that we are now at the beginning of the end of the pandemic, and it's looking remarkably promising. Doesn't mean to say I'm not seriously concerned about the next couple of months. I am. It's absolutely vital that we do all of the things that we know are going to slow the spread of infection down. Otherwise hospitals will be overwhelmed, and it'll be so ironic because we're going to end up losing some people in February, March, just weeks away from huge efficacy on the whole population being brought by the vaccine, and it would just be ironic and sad to lose people under such circumstances. Okay, thank you for watching, as always.